Good morning, good afternoon and good evening wherever you are in the world. My name is Darren Johnson and I'll be talking to you today about security dropboxes and their use with VPN pivots. Whilst the presentation talks about a Dropbox developed by myself, the OG150, you can use whatever Dropbox you like. There's a few on the market and you can make your own. Mine is really lightweight. It's small, compact and does the job, but then again I guess I am biased. So what do we have? We have a target infrastructure which consists of a firewall, a router and a metasploitable VM. Now the metasploitable VM is simulating a server on the target infrastructure which we, the pen tester, or could be an attacker, is trying to get access to. For those who don't know, metasploitable is a server or a device which is intentionally vulnerable. So it was brought out so that people could practice and hone their security techniques and make sure that whatever attacks they were trying to launch would work. So people use it for testing purposes or to help develop exploits. So we'll use that because it's easy to exploit for the purpose of a demonstration. Okay, so that's the target infrastructure. We have AWS on the internet, so Amazon Web Services, we'll come to that shortly. And we have the attacker's PC. So in this scenario, the attacker's PC is tethered to a 3G phone, an iPhone, which has a 3G connection. Now that's just purely for illustration purposes. That attacker's PC could be wirelessly connected to McDonald's or some coffee shop. It could be connected to an ADSL router at the attacker's home. The point is, the attacker is connected somewhere on the internet. Doesn't matter where, and from there he will be able to access this metasploitable server. Okay, so the first thing that needs to happen here is we need to deploy the Dropbox. Okay, if only it was this easy. Press a button and the box is connected. Now some of you guys might be saying, well, you need to get physical access to the network and we're really secure. And whilst that's true in some cases, it's definitely not true in all cases. Okay, even systems where you have to swipe to get into the building, they're still prone. People can piggyback the way in. So piggybacking is the concept of someone swipes in and you follow them into the office. You might have some heavy bags and the phone jammed to your ear, and people generally try to be helpful, so they keep the door open for you. Or you say, I'm here to see Jeff Smith, I'm running late, and they kind of let you through. Or I need to use the bathroom. Yeah, there's lots of different ways. I'm also working on another video. I don't want to go into it too much right now, but what that does is that completes this same attack scenario without actually entering the building. Okay, just briefly, what the demonstration will do is the OG150 will be connected to a remote controlled helicopter. The target's going to be my house. I'm going to land the OG150 connected to the helicopter on the roof, crack the wireless pre-shared key and continue the attack from there. Once I've compromised that VM, I then fly that helicopter back. I now have my OG150 and I leave. So anyway, that's really for another time. Okay, so those who've read my reverse SSH tutorial will know that it's pretty straightforward to connect the OG150, and upon boot it will automatically establish an SSH connection to your desired location. Okay, so what's happening here is the OG150 is creating an SSH connection to an EC2 instance. EC2 it's effectively a VM hosted by AWS in simple terms. This in particular is a Ubuntu server. It's free. I think it's called AWS free tier. So you just spin it up and you're away. So okay, so that's all automatic. So you've plugged it in, you've walked off site, the box is booted and dialed this EC2 instance in the cloud. Okay, that's great. What it also does automatically is it sets up a remote port forward function on the EC2 instance. And what that means is if anyone tries to connect to the EC2 instance on TCP port 10150, the EC2 instance will forward that traffic or that TCP connection over or inside that SSH connection to the OG150. Okay, hopefully that makes sense. It's a way of gaining access to the OG150 once the SSH tunnel has been created. Let's just demonstrate this. So on the Backtrack 5 machine, we initiate an SSH connection on TCP port 10150. That goes to the EC2 instance, which forwards it inside that pre-existing SSH connection to the OG150. At that point you have a reverse SSH connection to the OG150, and effectively you've now got remote access. So it's the first step, and it's an important step. Like I say, there's a dedicated tutorial on how to configure this on the website og150.com. Shameless plug. What's next? Okay, so from this point we have an SSH connection to the OG150. We can perform a vulnerability scan. Okay, see the little red dots doing the magic? Now I've called this a vulnerability scan. This could be an attack if you like. The important point to raise here is that you're restricted to the application supported by the OG150. Now this box supports all the usual suspects like Nmap and ARP spoofing and dsniff and all that kind of good stuff, but it's not a replacement for Backtrack 5. It was never intended to be. It's lightweight. It doesn't have the horsepower that a laptop has, obviously. So we're limited to those applications supported by the OG150. Okay, so what can we do? Because ultimately we want the Backtrack 5 machine to have access to this target LAN. So let's just see what happens if the Backtrack 5 tries to perform a scan, goes over the internet, and the firewall, you would hope, you would expect, would block the traffic. You know, I think it's fairly obvious to point out that companies shouldn't be allowing anyone on the internet complete access to their IT resources. That's hopefully a given. Okay, so what do? We set up another remote port forward function for TCP port 8150 in this case. So it's a second port forward. Same principle as before. Anyone tries to connect on TCP port 8150, it will get tunneled inside that initial SSH connection. Okay. We then activate the VPN server on the OG150. I personally use OpenVPN. You can use whatever you like, there's others out there. Okay, at that point we finish with the reverse SSH connection, so that can be disconnected now. We activate the VPN client on the Backtrack 5 machine, again just OpenVPN, and we start it. So we try and actively connect to the VPN server on TCP port 8150. Same principle as the reverse SSH. As previously discussed, the port forwarding will forward that TCP connection to the OG150. Okay, so that's great. So at this point we have a VPN connection from the Backtrack 5 machine to the company's LAN. Okay, really important step. So what does this allow us to do? Well, whereas before we had no direct communication to the LAN, we now tunnel the traffic all the way to the LAN. So notice how the return traffic actually goes back to the OG150. It gets encapsulated inside the VPN, the OpenVPN tunnel, and then it itself is tunneled inside that SSH connection. Okay, whilst all this is going on, the only thing the firewall sees, the only connection, is that single SSH connection on TCP port 22. Everything else is inside it. Okay, so in that respect, it's really stealth. Okay. Jumping ahead of the game. So the previous vulnerability scan has returned something back to the Backtrack 5 machine to say that the Metasploitable server is vulnerable on XYZ. Okay, so I now use Metasploit in the Backtrack 5 machine on the attacker's PC to exploit that server. Okay, and here you can see the payload. Same principle, over the tunnel, back out and into the Metasploitable. So in this scenario, the exploit payload was to create a shell connection from the Metasploitable VM back to the Backtrack 5 machine. Okay, and as you can see, hopefully the dotted yellow line is the reverse shell connection back to the Backtrack 5 machine. Again, goes inside the tunnel all the way back. So what does this mean? It means that VM is now compromised. The bad news is that Backtrack 5 machine now has shell access to the server, so let's assume that that device contains financial information. That user now has a lot of power. So the shell access with root privileges is similar to a DOS prompt with admin rights on a Windows server, and that's as dangerous as it gets. Interestingly, once this is done, you can then leverage other points of attacks. So you might then try and launch further attacks against the company router, and that would all be sourced from the Metasploitable VM. And yeah, people could start going down rabbit holes trying to find out who and what's being compromised. So that in a nutshell is how to deploy a security Dropbox and use it to compromise IT resources using a VPN pivot.